So last time we looked at solving exponential equations. This time we're going to look at solving logarithmic equations. And these logarithmic equations come in basically in 4 different flavors, so we'll take a look at one example of each type. So the first flavor is this very basic type that we've actually already looked at in class, where we need to, where we just have a logarithm that's equal to a number, and we can just translate this into an exponential and solve. So this says 3 to the second power is x minus 5, 3 squared is x minus 5, 9 equals x minus 5, and so x equals 14. So that one's pretty straightforward. So the next type of logarithmic equation that we could deal with is one like this, where we've got two logarithms with the same base. And if it's possible we can get two logarithms with the same base equal to each other, then we're going to be able to solve pretty easily. So for example, I can add log base 5 of 2x plus 1 to each side, and I get log base 5 of 7x minus 3 equals log base 5 of 2x plus 1. So at this point we can actually just say that basically the insides of these logarithms are equal. And the reason for that is we remember that the logarithm is the exponent. So this is, the logarithm on the left says the exponent that we raise 5 to get 7x minus 3 is the same as the logarithm the same as the exponent I raise 5 to get 2x plus 1. So in that case we must have that 7x minus 3 equals 2x plus 1. Another way of thinking about this is I could just say, in the middle here, let's raise 5 to the power of each side. So 5 to the log base 5 of 7x minus 3 equals 5 to the log base 5 of 2x plus 1. And by the inverse property of logarithms, I get that blue equation. And from there, it's pretty easy to solve. I get 5x equals 4, and so x equals 4/5. So I got a little bit bogged down in explanation in the middle, but the basic idea for solving these, when I've got the same base, only if I have the same bases here, is I get that, so one logarithm with the base is equal to another logarithm with a different base, and then I said that the insides are equal, and solving from there. So another flavor I have to deal with is one like this, where I just need to recognize that I can apply rules of logarithms. For example, I can look at the left side of this equation and say that's 2 log base 4 of x equals 7. I can divide each side by 2, so log base 4 of x equals 7/2. And at this point I'm actually back to something like that first example I did. I can say this means 4 to the 7/2 equals x. And now I recognize that 4 is 2 squared, so I get 2 squared to the 7/2 equals x. And by properties of exponents, that's 2 to the 7th equals x, because I multiply the exponents 2 and 7/2. And finally that means that x is equal to 128, which is 2 to the 7th power. Now here we have the final, most challenging type of logarithm problem, because this one's actually going to hark back to chapter 5 a little bit. With a problem like this, we're going to start by using the product property of logarithms and say that this left side is the same as log of x times x plus 9. That equals 1. And we have that log then of x squared plus 9x equals 1. And now we are again back to that first situation where I say, okay, I remember this is log base 10, so this is the same equation as 10 to the first power equals x squared plus 9x. Well, now I've just got a normal quadratic equation, and I can say this is the same as x squared plus 9x minus 10 equals 0, and so that's x minus 1 times x plus 10 equals 0, factoring, and so I get x equals 1 or negative 10. Now with these where we have this quadratic situation arising, we always need to check our answers because they don't all always work. So let's start with x equals 1. I'll plug that back in up here, and I get log of 1 plus log of 10. Well, log of 1, that's 0. Log of 10 is 1. And 0 plus 1 is 1, which is good because that's what we're looking for right up here. However, when we try negative 10 up in here, we get a log of negative 10 plus log of negative 1. And we can't actually do the logarithm of a negative number, so this negative 10 answer is not actually a solution to the problem. The only answer is x equals 1. And just as a brief refresher, the reason that we can't have the logarithm of a negative number, this would say to us 10 to what power is negative 10? There's no power I can raise a positive number to get a negative number. So that's why I can never take the logarithm of a negative number. And if you remember looking at the graph of logarithmic functions, we never have any negative x values there. That's why. So again, with these logarithmic equations that end up with quadratics, please make sure you check your answers. Please prepare the following 3 problems for class. The first 2 are logarithmic equations like we just discussed. Please make sure that if appropriate you check your answers. And question number 3 is solving an exponential equation, just to keep us sharp on what we did yesterday. So I will see you in class tomorrow.